to solve each equation, the radicals. These are both to the third root, so third root means that they effectively undo each other, right? Because if I raise this side to the third, raise that guy to the third, they're both inverses, so they would basically knock each other out. And there we go. So now we would solve this like a multi-step equation. Make this guy go over there. Alright, so now we get a 3x equals 12, and x has to equal 4. Let's double check. Radical 4 is 20. Is that right? Did I just mess up? I'm trying to go too fast. Why is this? Wait. I don't. Why I wrote 3? Yeah, it didn't make any sense. That's 2. That's 6. I was gonna say 4 doesn't work. All right. Okay. I can't edit this out either. This is just a total freestyle. So 6. So 30 minus 16. Then that would be radical 13. Yes. Okay. So that checks out. That's good. All right. 53. Now this is different because this guy has a radical, but he doesn't. So let's see if I can zoom in here. Great. What I'm going to do is I'm going to square both sides. Okay, and in one step, I just turn this radical equation into a quadratic section from, or the quadratic questions in the last section. So we're going to move all these guys over to the other side. Okay, and that is specifically so that it equals 0. But we want our a value, that is the coefficient in front of the quadratic term here, we want that to be positive 1, so then that way it's factorable. I'm looking for factors of negative 30 that add up to 13, and I know that that's a positive 15 and a negative 2. So that means u plus 15 and u minus 2 equals 0. And I don't have to divide by anything because, well, it's just a 1, so dividing by 1 just keeps it the same. So it looks like u is negative 15 and positive 2. Now let's just check and make sure. Well, first of all, if u is negative 15, you can see a square root value equaling negative 15 will not work. Okay, so let's see. 2 is okay. So 26 square root of 4 is 2. So 2 is actually the only real answer there. Here, I have to undo this 4 over 3, so it will definitely be a 3 over 4. But I need to isolate them first. So let's make sure that we take care of this here. So negative 2, 3b. We've got a lot going on here. So I've got to subtract the 7. Then I will divide by negative 2. Then I will do the 3 over 4 root and raising root because it's doing both at the same time. Then the final step I will divide by this guy 3. So we got to do these in order. So let's go ahead and do this. That's going to be negative, and then that would be a 162. Now let's divide by negative 2. So that's 3b, not 36, but 3b. And that's going to be a positive 81. Okay, so now I'm ready to raise this guy to the 3 over 4 so that this becomes 3b. Okay, now let's shrink. Let's do this in our heads. 81, what to the 4th power gives you 81? Okay, we're going to take the 4th root of 81. Now in the calculator, let me show you, you can do that. You can take the 4th root. If you hit the math button here, you'll notice that you have a 3rd root, and then you've got this guy as an x. If you go to this guy, now this is the math button, by the way. If I hit enter, I can type in the 4th root there. Okay. Then if I push over 81, this is a quick way to find that there is 3. That 3 to the 4th power is 81. So That's 3. Now I got to raise 3 to the third power. I took the 4th root of 81. Now let's raise it to the third power, and then that's going to be 27. Okay? So now b, after dividing by 3, b is 9. Okay, so let's plug in 9, 27, 3 to the 4th, 81, 7, yeah, okay, so this checks out. We're good. Okay? So, good stuff there. Rational equations. Yes, we can fit this into here. We've got, don't like this. This is almost the same thing. So we got to set these equal to each other, and then that way the denominators can get gone. If I switch the order here, okay, and I am going to write this out here, I can get k minus 4. Alright, so this means then, if I just move this guy up to the top here, okay, then I'm going to have the same common denominator. Now, if you ever have a positive numerator and a negative denominator, or a negative sign in the denominator, just make them float up, because in the denominator, he's easy to get lost. Okay, he gets lost, let's move him back up to the top. So these guys are good. Okay, it's just that k cannot equal 4. So watch out for 4. If 4 comes out in your answer, you know it's wrong. Okay, so we're going to distribute the negative sign to this. Okay, so we're going to do this. 6, right? So negative k equals 8. So k equals negative 8. Okay, negative 8. And negative 8 checks out because that would be a negative 2, and then we swap. Yep, okay, so this guy checks out. Okay. Next one. This guy has a u minus 2. He has a u minus 2. So if only this guy had a u minus 2. So we are going to have to give this guy a u minus 2. Okay, now our u cannot equal positive 2. Okay, so watch out for this as an answer, because 2 would be a division of 0. Just like up here, k equaling 4 would give us a division of 0. Can't do it. So that's something you have to watch out for rational equations. Right? It's just you cannot divide by 0. Watch out. Just like over here, we can't have 5, can't have negative 1. And my guess is that's both of those put together. Alright, so let's get this guy a u minus 2. Alright. Okay. So, looks like these guys are now even. Okay. So I'm going to get a u squared plus 3u minus 2u minus 6 equals u squared plus 3u minus 4 plus 3. So I'm going to add them up on each side and then see what will go away. U squared plus u minus 6 equals u squared plus 3u minus 1. Okay, now both of these guys will actually cancel out, because if I added negative u squared to either side, they're going to go. Let's go ahead and move this guy over to here, and then we'll move this guy over to here. So negative 5 equals 2u. So u equals negative 5 over 2. And let me verify that. And that is correct. As long as we don't equal 2, we're good to go. Okay? And here. Okay, stop there.